So once we are done with the laser configuration, we can move to optional tools in order to optimize our use of the laser. In the drop-down menu of the optional tools, we can find the laser dose array test, the laser power calibration, and the laser efficiency calculator. So now we will focus on the laser dose array test. The laser dose array test is a tool that provides functionality to evaluate the quality of laser writing under different parameters. We can see from the software that we can change the pixel size in Y with its different steps, the laser power, and also some fixed values such as the pixel size in X and the pixel time. In this way, we are able to evaluate initially graphic optically, observing our camera, and then we can also observe with our nanofraser with the reading functions the ability of writing with the laser on our specific substrates. So let's have a look how this laser dose array test works. And in this case, let's say we want to keep this pixel size of 100 nanometers in X, but we want to change in Y. So as you can see from this graph of the expected array, if we reduce, for example, the pixel stop in Y, we will see that the graph will be reduced in terms of windows along this axis. So let's put 200, for example. And we see that we only have two different pixel size in Y. We can do the same for the laser power. Let's say we want to change the laser power stop at 200, and we put the start at 50 with a laser power step of 50. So we can also change the pixel time in case we are interested of evaluating also different pixel times. We have to keep in mind that this value is always constant. So let's put 50, for example. Okay. Of course, a shorter pixel time will make the writing a little bit faster. In this case, we reduced it. So the whole process is going to be a little bit faster. Why not? Let's add also another row to Y. So let's put 300. And we can estimate the time of the process. It's around 3 minutes. And we can let it run and wait until it's completed. To have a better view of what's going on, we can also go to the utilities in the camera. We can see the process happening live. So in this case, we will start from the first row as generated from this array here. So we will pattern at 100 pixel size in Y with 50 milliwatt laser power. We can already see that now we saw the laser the laser spot, sorry, and with an increase in pixel size in Y, we were not able to write. So this is an indicator that tells us, okay, at 50 milliwatt with 300 nanometers pixel size in Y, we are not really able to write in our PPA. Let's also not forget that when we evaluate our capability to write in any substrate, it's very important to define which kind of substrate we have, which kind of stack we have. So now, as mentioned at the beginning of the videos, we're using a 10% PPA on silicon, which is a good stack for training, but it's a stack that's not really used for application and pattern transfer because there is no underlayer below the PPA. In general, when we want to use practical stacks that we use for our transfer, we can use another advanced functionality to have already an idea whether the stack that we're using can have good efficiency for our laser. And this we will see in the later video for the laser efficiency calculator, which is quite useful tool to determine whether our stack is a good stack or a bad stack for writing. So in this case we can see kind of the limit at which we're able to write, which is around 50 milliwatt. For the other laser power, around 100 and 150, we're able to write quite well. Now we're just doing the last row of the 200 milliwatt power. Okay, so now our test is completed. As you can see here, we have these 4 different rows that we create in the laser configuration in the laser dose array test, so 4 by 3. And yeah, this is pretty much it for the laser dose array test. In case we want to have a better understanding of the depth, for example, at which we are writing, we can always go to session and select specific squares that we're interested with the read arbitrary function, and we can measure the depth of a specific square, because when we are doing pattern transfer, we're also interested in knowing the depth at which we are writing with the laser, so that we can have a successful pattern transfer, and also read the whole maybe 2 squares to make it even more effective. Just be aware of where you place the flattening to avoid issues.